All right, everyone, welcome back to homework 3.3. We'll be graphing some lines. I know that the lines on my graph are not showing up very well on the screen here, but that's okay. I can see them. So just understand that as I count to the right and up or down, it is going by increments of one that follow the lines on the grid. So there's a few ways to graph these darn things, and I'm going to go through both of them initially, and then I will stick with my preferred method after that. So the way that I would prefer to do this is to use the y-intercept and the slope to graph them. And so I'll do that second, but what I will do first is show you an alternative way to do this. So one way is to say y equals 3x, and then just pick a random x value to put in there. You could pick any number. It could be negative 1,000, it could be 127, it could be 83. In our case, we would want to pick something that would produce a value that would fit on the graph. And one of the things that I will typically tend to pick first would be something like 0. So like y equals 3 times 0. And 3 times 0 is 0, so y equals 0. So what that really says is when x is 0, because I put 0 in for x right there, y is 0. And that's because we can see that because y came out to be 0 right there. So the ordered pair that would be associated with this would be the ordered pair 0, 0. Now the way that we can see that in the equation over there on the left is that the slope is 3, but there is no y-intercept there. What really is there, though, is a plus 0. We just tend to not write it. So we would be able to say that the y-intercept for this is 0, which would have us putting a point right there. Now we need a minimum of 3 points for this. And so I'll go ahead and do 2 more with the way that I did this one on the right. And so I'll choose another value like x is 1, for instance. So y equals 3x. I would be able to put 1 in there for x, just like this. And it would produce a y value for me, y equals 3 times 1, which is 3. So what that says is when x is 1, right there I put 1 in for x, y is 3. And that's right there. So I get the ordered pair from there that x is 1, y is 3. And so on my graph, I could come over and go to 1, 3, and put that there. Another one, we need a minimum of 3 points. Again, we could put in a negative number if we chose to, like -1 or something like that. I would go ahead and personally stick with the theme of going up in increments of 1, so y equals 3x. I will choose 2 this time, y equals 3 times 2, y equals 6. So this says when x is 2, y is 6. So again, I put 2 in for x, and what came out of it was of the y value 6. So our ordered pair would be 2, 6. Okay? So I've got my 3 points, and therefore I can go ahead and sketch a graph of this darn thing. And as I mentioned a moment ago, this is not my preferred method of doing this. This is time-consuming, it's laborious. There's a better way. And the better way, for me, I'm going to go ahead and show the better way in blue, is to use the slope and the y-intercept to my advantage to do this. So what I would say, I'm looking for a blank space here, my slope is 3, which is the same as 3 over 1. My y-intercept is 0 because there's no constant attached to the end of that equation. So my y-intercept is 0. I would start here at 0 like this, and then I would recognize that my slope is 3 over 1, remembering that the 3 is the change in y, and that the 1 is the change in x. For me personally, I will always use slope to go to the right, because it just makes more sense to me, and it seems to make better sense to students. So if I start at 0, at the ordered pair 0, 0, This 3 over 1 tells me to go up 3 and to the right 1. And then again, up 3 to the right 1. And you would see if I do it again even and make a fourth point, up 3 and to the right 1, I still land on the line. So the way that I'm going to go about doing these from here forward is going to be to use the slope and the y-intercept to do it. If you're a person that chooses to put x values in to produce y values and then make an ordered pair like I did in my work in the green, that's okay. Recognize that that's not very efficient, and that I would encourage you to do it the way that I'm going to do it, which is using the slope and the y-intercept to do that. Okay, I will leave this here for a moment, and then I'm going to move on to the next problem. All right, so we've got the next one. We have y equals 3, where is it? Negative 3x minus 1. So y equals negative 3x minus 1. My slope is negative 3 over 1. My y-intercept, and it's important, I do this often. Remember that the negative sign that's in front of these numbers, in the case of the minus 1, yes, it's minus 1, but that negative is attached to the 1, so my y-intercept is in fact negative 1. So for the way that I would graph this, I would start with the y-intercept. My y-intercept is at negative 1. And then my slope would be negative 3 over 1. So a lot of times people get confused and say, okay, is this a negative 3 over 1 like that? Or is this a negative 3 over 1 like that? The trick is to know that the three things that I'm going to circle in red are all equivalent. They all mean the exact same thing. Typically, we do not see fractions written like this, the last one there. We'll normally see them like the first one or the second one, but recognize that those are the exact same thing. Typically, the way that I think about it, especially when we're dealing with slope, is to use this one, because it will tell me as I go to the right, do I go up or do I go down? And so remember, the change in y is on top, and that tells me up or down, and the change in x is on bottom. That tells me side to side. So what this is telling me, this slope right here, is telling me to go down 3, because it's negative 3, and right 1. So I am going to go ahead and use that information from my y-intercept that I had to go down 3 and to the right 1. And then again down 3 and to the right 1. And then I could do it again down 3 and to the right 1. This is my personal preference for doing this, folks. If you choose to do it by putting in values and solving the equation over and over and over again, good for you. Go ahead and do that. But I am going to use the slope and the y-intercept each time as I do this. The thing is, though, that if you do it a different way and you come up with something different, understand that that will be incorrect, and that regardless of the method you use, you should come up with the same thing that I do. Okay. I will pause here for a moment so you can pause the video if you need to, then I'm going to move on. Okay. So we have in this case, and this is a bit of a weird one, y equals 3. And so what we've got is, again, I'll do the thing over here, y equals 3. Our slope, there is not one. So in the case of there not being a slope or there not being a y-intercept, it is 0. And our y-intercept, remember, our y-intercept is the number that is not attached to x. It is the constant. Our y-intercept is 3. So with the slope of 0, another way of writing 0 is 0 over 0. What that says is we do not go up or down at all for any side-to-side change. And our y-intercept of 3 says that if we come up to 3, this line is going to be 3, located at 3, no matter what, because the slope is 0. So it is not increasing or decreasing as we move side to side. Remember, division by 0 is impossible, so the only thing that is really going on there is we're saying that there is 0 up or down movement. And so I graphed a whole lot more than 3 points in this case, but basically that's what we've got, is a line that is hanging out right at y equals 3 for the entirety of its life. Okay, I will pause and then move on. Next, we've got another one that's a bit weird. We have x equals 2. You may be thinking to yourself, where is the y value here? There isn't one. So the thing about this to understand is that there is no y-intercept, because this line is never going to cross the y-axis. What's true about this is that this is saying that no matter what happens, the line is going to be at the value x equals 2. So let's go ahead and just mark a few of these at x equals 2. And we can see that if we do this, that we would have a vertical line that stays on the sort of a row of points at x equals 2. Again, this one, number 4, and the one previous, number 3, are a bit odd, and they often confuse people. So if you feel a little bit confused by this, don't worry, you're normal. But I would focus more, if we were face-to-face in class, on things like number 1 and number 2. 3 and 4 are sort of an honorable mention, but not really something that's going to be important as we move forward. Number 5 is something that is going to be important. We're back to having a slope and we're back to having a y-intercept. So let's have a conversation about that. Again, super important. Y equals 3 over 2x plus 3. And again, the way that I would approach this is my slope is 3 over 2. My y-intercept is 3. So I would mark my y-intercept at 3. And then my slope is positive, so I'm going to be going up 3 and then to the right 2. So again, up 3 and to the right 2. Up 3 to the right 2. Okay. And so I've got my 3 points. I can go ahead and sketch my line out here. And there we go. It'll look something like that. And again, if you wanted to do things like put a 1 in for x and figure out what y was going to be, that's fine. Feel free to do that. It should work out fine. Just make sure your graph comes out looking like mine. Okay, I believe on to the last. Yep, we're almost done. Hallelujah. So the equation of the line is given below. We have 2x minus 4y equals negative 12. We're asked to find the x and y intercepts. And so what we need to understand is that the y-intercept happens when x is 0. And so the way to handle this one is going to be to say, okay, I've got 2x minus 4y equals negative 12. I need to figure out the value of y when x is 0. So let's change x to be, let's assign x a value of 0. Almost forgot my negative on my 12. And so 2 times 0 is 0. So I'm going to have negative 4y equals negative 12. I'll divide by negative 4. And I get y equals positive 3. So my y-intercept is when x is 0. My y-intercept is positive 3. So we will do the same thing to find our x-intercept. So this time we will put a 0 in for y. And so we have 2x. Negative 4 times 0 is 0. So that is equal to negative 12. Oops. And we divide by 2. X equals negative 6. So the line is going to cross the x-axis at negative 6. and we're supposed to label each intercept with the corresponding ordered pair. So this will be 0, 3. This will be -6, 0. Okay. And then we need to sketch a line. So there we go. And that's going to be it for that one, folks. My x-intercept is -6, 0. My y-intercept is 0, 3. Okay. Moving on to number 7. Find the x and y-intercepts of the equation given below. Express your answer as ordered pairs, show all your work. Great, perfect. So we got 4x plus 2y equals -8. 4x plus 2y equals -8. Let's go ahead and put 0 in for x first. This will give us our y-intercept. And so we divide by 2. We get y equals -4. So the ordered pair here will be x is 0, y is -4. And that's my y-intercept, not my x-intercept. And then over here, we'll go ahead and put 0 in for y. And we get 4x equals -8. Divide 4. And x equals -2. So our x value is going to be -2. Our y value is going to be 0. And so, folks, I believe that is going to be it for this homework assignment. Let's check and make sure that there's not one more hanging out here at the end somewhere. Nope. So that is indeed it. I hope this is helpful, and I hope you have an awesome day.